And without further ado, I want to introduce our first speaker, which Josh, as Josh already said, our first speaker is Evan Murray. Hello, Evan. How are you doing today?
Doing pretty good.
Great. So yeah, you're studying music technology at the Georgia Institute of Technology, as Josh already said. And you have been doing some programming on the Gameboy Advance.
Yeah.
So that's really exciting. Today you're going to talk to us about how that went and what you learned from that.
Exactly,
so, Yeah, really looking forward to that.
Great. So we have a pre-recorded talk from Evan today, and then we're going to do a Q&A afterwards. So just a reminder that if you have a question, be sure to type in big letters question and then ask your question so we can ask it afterwards for Evan. And without further delay, here we are.
Hi everyone, my name's Evan and I'm a student at the Georgia Institute of Technology. And as a person who studies music technology, I thought it would be a good idea to try and make sound with my Game Boy. How did I get the idea to do this? A couple months ago, my brother came over to the house to go through his stuff, and one of the things he pulled out was his old Game Boy Advance. He had some interest in it, but then gave it to me when he saw my eyes widen. I played some of my favorite games on it for a couple of days, and then a thought popped into my head. This device is a gaming console, but it is also a computer. Therefore, it has to be programmable somehow. What programming language does it use, and could I program my own Game Boy Advance programs? I remember hearing there is a computer science course at my school which teaches Game Boy game development through C, and they use a tool called Tonc. So I head over to the Tonc website and I read through the introduction a little bit, and I recognized words such as makefiles. Makefiles, they were familiar to me since I had previously used them to build my projects in hackathons or some example audio plugins that I tried building during the spring. And they're essentially a script which goes to the compiler and tells it what to do with all the source code. To get that compiled into a GBA file, I used a compiler called devkit-arm, and this compiler is part of the devkit Pro toolchain, which includes many other compilers for the 3DS, Nintendo Switch, and Nintendo DS. So after this GBA file is created by the compiler, it can be run through an emulator or directly on the Game Boy Advance using a flash card. Once I was able to compile a few simple programs for the Game Boy Advance, then I started to learn audio programming on the device. Although you might be writing some code in C or C++, there's a lower level part of this process. On the Game Boy Advance, there's no such thing as an operating system. So when you're running sound programs, they're being processed directly by the CPU and sound registers, which control the sound hardware on the device. To get the Game Boy Advance sound chip to do certain things, you need to change different values stored inside different sound registers. And often it's hard to associate these registers just by their numbers and try to remember what each one does. But luckily, C gives us a useful tool to work around this challenge. In C and C++, you can use define directives to give a name to each register. Therefore, whenever I want to write a value to a register, I can treat it as a variable and have it be associated with a specific thing. This pattern of naming registers with defines is used in the Tonc library, so you can use those defines when you import the Tonc library into your code. Creating sound on the Game Boy Advance is all about setting the right values to the right sound registers. If you set an invalid value to a certain register, it may not work. For this reason, there are guides out there which help you identify the correct values to set for each register. One resource I used which helped me was belllogic.com. They have a whole memory map of all the sound registers and what bits you need to set for each one. This can be challenging to follow since each bit makes a difference in how the sound behaves, but if you try enough, you'll start to get the hang of things. Let's walk through creating a simple sound program in C. First, we'll import the Tonc library with the register defines into our code. Then we'll create an entry point, and inside that entry point, we follow these steps to set up the sound. We'll turn on the sound chip, then we'll set a master bus, and we'll do that by first picking what kind of wave we want. So with the original Game Boy, it came with one tone generator, which is a sweep, another tone generator, which doesn't have the sweep, and then a third tone generator, which can be a custom wave, and finally a noise generator, which can be used for all the drum sounds. And then this wave, we can have it have a maximum volume of 7, so I'll set it to that. In the Game Boy Advance, how is it different from the original Game Boy? Well, you can load 8-bit audio files, or you can use the 4 original pulse channels from the Dot Matrix Games Game Boy. And that's what that Dot Matrix Games is. It's the code name for the original Game Boy. But for now, I'm just going to use the DMG channels. So we'll set the DMG to audio ratio 100%. So it's all pulse channels. And then we're going to turn the tone 1 sweep function on, and we'll build that sound in envelope. So we can set the max volume. You can set a volume from 0 to 12, and then does the envelope decay or increase, 0 or 1. I'm going to choose decay, so we'll pick 0. And then a max step time, we have a max step time of 7, or you can do anywhere in between. I'm going to do, let's say, maybe 4. And then we can select the duty cycle. So what are the duty cycle? Well, the duty cycle is how long that wave is being pulsed. And then finally, we'll initialize the sound frequency to 0. So now we just need a way to play our sound. To do this, we'll create an infinite while loop at a controlled speed, which periodically checks to see if a certain button is being pressed. And when that button is pressed, we'll have our sound be played. So in this example, I'll use the A button. Okay, great. Now let's write a function that plays the note. So when a note is played, what we need to do, we need to first reset the frequency of the sound, and then we need to set the frequency and octave, which are loaded into the function. Lastly, we run this function whenever the A button is pressed. Okay, so now that we have our program, to turn this code into a Game Boy Advance program, we need to use a makefile template. And that's included inside the Tonc code folder, which you can download from the Tonc website. And once we have that template, we can just edit it and insert the location of where the Tonc libraries are installed on our system. And it's also important to run these 2 commands that tell make where the devkit arm compiler is located. And once those 2 steps are done, we can run make inside the folder to generate a GBA file. And then we can put that GBA file on a micro SD card or run it through an emulator. And I'm going to choose to put it on the SD. So once we load that SD into this flash cartridge, we can just play it like a regular Game Boy game. So let's go ahead and see how this sounds. All right, so here we have it, the flash card. Then we go to the program. It's a blank screen because we didn't do any graphics. But if we press the A button, hey, there's the sound. And you'll notice we set the sweep function to be on, but it's not playing because I haven't actually set it up. I'll go over that in maybe a future video, but I don't have time to do it here, so we'll just skip over that for now. Making simple sounds is fun and all, especially once you've mastered them. However, many professional games will use other digital signal processing tactics to manipulate the sounds. I noticed one of my favorite games, Super Mario Advance, used a vibrato effect in one of the minigame songs. The idea of figuring out how to implement this effect was like finding a treasure chest. It took me 2 days. I sat down during the evening and thought logically through what was happening with the sound during the vibrato. It was essentially sweeping the frequency up and down multiple times. Isn't that what the sweep tone generator is for? Well, I tried using it, but it was too difficult to control. Maybe I could try to sweep the frequency manually. I just needed a way to control the time of the sweep. The GBA CPU runs too fast for an effect to be noticed. So to get around this challenge, I tried something which worked, the refresh rate of the screen, or the V-blank, and that happens around 60 times a second, or 60 hertz. So I decided I could create a couple of loops and change the frequency inside of them. How would I be able to control the speed? Well, to make the vibrato go slower, I would just increment or decrement the frequency, say by 1. And if I wanted to make it go faster, I might change the frequency by a value of 5 or 10 each time the loop goes through. and I could increase that to whatever I wanted to until the vibrato is eventually going super fast that you can't even tell that it's vibrato. It just sounds like its own frequency. I was so happy when I figured this out, but I wasn't satisfied yet. The same day, I was playing another one of my favorite games, 102 Dalmatians, which is a Game Boy Color game. And this game also used some fancy audio effects such as quick arpeggios. After listening to the arpeggios, I realized they are similar to the vibrato. The only difference is that through the loop, the frequency is changed discretely to different notes instead of frequencies in between. I tried implementing this effect after thinking about this, and I was able to get it to work in a little less than an hour. After messing around with my Game Boy Advance for a couple of weeks, I was still left with a couple of questions. Why is retro music still popular these days, and how can we combine it with modern technology? Well, there's this book I'm reading which describes the phenomenon of how certain music may bring up feelings like nostalgia or memories from our childhood. Some of these memories are positive and create a desire for retro gear. And because of this, there's several YouTube channels which still focus on retro equipment. In addition to creating nostalgia, the 8-bit square waves and noises are harmonically pleasing to some ears. And there's even a market for these types of sounds in music. For example, a company called Teenage Engineering sells a product called Pocket Operator Arcade, which has a collection of 8-bit sounds. This train of thought brings me to our next topic. What is the function of retro music in modern music? And could we expand the timbre and expression of retro music through modern tools? The answer is yes. We are limited by the sound parameters the Game Boy Advance provides us in the data dimensions, which are 8-bit. However, we can change those parameters in any way we wish. In fact, there is a product called the Arduino Boy, which allows the Game Boy and Game Boy Advance sound engine to be controlled through MIDI. And this can be useful for keyboards, and it also opens the doors for more expression. Personally, I came up with an idea to combine AudioKit, a tool for developing mobile music applications, and sounds from my Game Boy. And this allowed me to create a Game Boy instrument on my iPhone. Eventually, I'd like to have AudioKit control the Game Boy directly, but for now, I am using pre-recorded sounds. I'm looking forward to the future things I discover with Game Boy music, and I'll be posting updates on my YouTube channel, EV Music, if you're interested in following. But thank you for coming to this talk. I hope you enjoyed it and learned a lot, and now I'll be taking some questions.
Thank you so much, Evan, for that brilliant talk. And yes, we're going to take some questions. What questions do we have, Teamer?
Yeah, so we have a few questions on the chat. Thank you, by the way. Thank you so much for the talk. That's really cool stuff.
You're welcome.
So one question from Stu. So on the Game Boy programming, wouldn't the frequency define the octave so that A's are 440, 880, etc.? What's the purpose of the octave?
I'd say the purpose of the octave is just to sort of make things easier, because a lot of the times as a musician, that's kind of at least how I think as a musician. Some musicians, they might think in frequency, especially when involving tuning. But in my case, it's just easier to think in octaves, and Tonc already had the defines for that.
That's great. I actually had a question. Where was the original vision to start on assembler rather than starting right away with something that has higher level of abstractions like AudioKit or Juice? Where did that motivation start from?
It actually came from when I was around in 5th grade. I got this card called an Action Replay, and basically this device that allowed me to enter in cheat codes on video games. And I had no idea how the thing actually worked until like a couple years ago. Then I found out, okay, it's actually changing the certain addresses in the game, like maybe one's for the score or something. And I just thought that was really cool. So it kind of inspired this stuff.
And had you been programming before university? Because one thing that I think is that as a second-year student, your programming skills are quite advanced. You've gone a lot deeper than most students, or I know I was nowhere near this when I was in my second year. So were you developing before you went to university?
Yeah, like I said, since 5th grade, I've kind of been interested in computers. And then around 8th grade, I was curious on how I could make my own app. So I always wanted to make an iPhone app. So I got a developer account and started learning Swift. And that was one of the first programming languages I learned.
Very interesting.
Right. Yeah, we have a few more questions. So Mark is asking, is the hardware ever different from the emulator in terms of the sound produced?
I've noticed a couple things also there were some bugs where the emulator would work. Like one of the times I was trying to program it and I was programming the wave channel and I got a sound kind of like the startup of not the Game Boy Advance, but the Game Boy Color, where it's kind of this certain sound. And yeah, it's just sometimes the emulator handles things differently, but then if you try it on the Game Boy, it will actually crash if there's something wrong and it just won't work at all. But that's really the only difference I notice. The sound is pretty much identical.
That's interesting. And that actually leads to the next question, which is whether you have any plans to program on the original Game Boy.
Yeah, I've thought about it. I know that the flashcards are harder to get a hold of. I know the Game Boy Advance is common because it's the Easy Flash Omega, but I've definitely thought about it, and I think it'd be useful to combine both the Game Boy and Game Boy Advance, so that way I could have more channels for sound.
So actually, I have a question here. So the original Game Boy, does it have the same sound chip? I think it has less things it can do, right?
Yes, I spent about a week researching that because I was just curious about it. And there's not really any details on what sound chip it uses. But I've talked to my dad. He was in the semiconductor industry for 20 years. And so he was telling me how even one chip can contain multiple integrated circuits. So what I'm thinking is that there seems to be no reason that the programmable sound generator in the Game Boy would be different from the Game Boy Advance. And I think they both include the same chip, but it's just that the Game Boy Advance also has 2 audio stream channels, so you can load audio files.
Yeah, that's really exciting. I have to admit, actually, when I was that age, I wasn't into the Game Boy. I had a Game Gear, which was the Sega one, which had the color.
Yeah.
It was in 1990. And so, yeah, when I was 7 years old, I was really addicted to that. And then much later, I looked into that a little bit. What would it take to write a sound emulator for the Game Gear? And it was a bit different. It had I think 3 channels and a noise generator, but there were some differences to what you were saying, but I never actually had the time to look into it properly. But now you motivated me to go back there and spend a bit more time with this because it seems to be so much fun.
It really is. Yeah.
Right. So we have one more question, actually, I think. So Jack is saying, first of all, thanks for the great talk. So can you talk about the Georgia Tech program? I guess okay, that's a bit of an off-topic question. I'm not sure if you need to maybe you should take this offline. I'm not sure. But there's someone who's asking the same question. Can you maybe just say a sentence or two about the program where you're studying, because people seem to be really interested in that.
Yeah, so the program they have at Georgia Tech, everybody's a music technology major because that's what the program is. But there's different concentrations, and the one I'm interested in doing is minor in computer science. So that's kind of the area of study that I'll be doing, and probably taking some programming classes later on. But you can also do things like mechanical engineering, and also I think there's acoustics, a lot of different other routes that you can go. But yeah, it's a great program so far for the first year.
All right. Well, yeah, sounds like fun.
Yeah.
All right. Thank you, Evan. Thank you so much for this really interesting presentation. That was really
Thank you for having me.